Um, hi. So as you can see, most of our notes are going to be on the graphs because, yeah, there's nothing on the white sheet of paper. Yeah, so if you need graph paper, you might want to grab it. We're going to go through the four types of graphs, and then I have 5 examples. So hopefully it won't take forever. So yep, all the rest of them. Not really harder. Yeah, secant stay at the bottom. I just got to move the paper out. Okay. So let's go through tangent again. All we're going to do is we're going to get the points off of the unit circle. Now, start off like what we did with the others with tangent. With tangent, if I go to 0, remember, tangent is the y value divided by the x value. So at 0, what is tangent going to be? 0. Okay, at pi over 2, what's it going to be? Oh, it'd be 1 divided by 0, which is undefined. So at pi over 2, I'm going to have an asymptote. Okay, what happens at pi? 0. Okay, 3 pi over 2. That's negative 1 divided by 0, so that one's undefined. Now, just because I know what it's going to look like, I'm going to stop there and I'm going to actually go backwards. At negative pi over 2 is also down here. Okay, so that didn't help us out a lot. I have a bunch of lines and dots. So, to help us out, what I'm going to do is I'm going to use pi over 4. 1. Right? At pi over 4, tangent is equal to 1. Yeah, undefined would be a vertical asymptote. So pi over 4, I am equal to 1. So let me put 1 and negative 1. Okay, so let me just take care of in between these asymptotes. So let me do negative pi over 4. So negative pi over 4 would be down here. So what am I equal to at negative pi over 4? Negative 1. Okay, so at my asymptotes, you go up or down forever, right? So what this is going to look like is it's going to look like this. So kind of like an x cubed graph, except for it has asymptotes that it has to stay within. So it goes up and down forever in between there. Yep. So at the at the 90-degree marks, it's going to be 0, which at 0 and pi, it's going to be 0. So we have to go in between those. At the pi over 4 marks, it's going to be 1s and negative 1s. So pi over 4, negative pi 4 is going to be 1 and negative 1. So in between this one, we're going to get the same exact thing because it repeats, right? So all trig functions repeat over and over again. Yep. Asymptotes. This? Yeah. That's an asymptote. Its tangent is undefined right there because at pi over 2 we get 1 divided by 0, which is undefined.
So how do you get the point of
The pi, like this point, okay, at pi I'm equal to 0 divided by negative 1, which is, no, 0. So at pi I'm equal to 0. At 0 I'm equal to 0 because I have 0 divided by 1.
So how would you know if it repeats?
All trig functions repeat because we keep going around this circle over and over again. So once I've completed my circle, I'm just getting the same values again.
So you just basically repeat it by
So I could just keep going. So my next mark is going to be over here. That's going to be my next dotted line. I know on each of the pi marks, I'm going to have a 0. At each of the half pi marks, I'm going to have a dotted line. And then I'm going to have a 1 and a negative 1. I'm going to go like that. So again, with a lot of these trig functions, you just need to figure out the pattern. So you know over here, here's a pi mark. So it's going to have a dot. At the next half pi mark is going to be a dotted line. And on the right hand side I have a 1. On the left hand side I have a negative 1. So I could just keep doing that forever. Now, cotangent, instead of going back to the unit circle and doing all this all over again, let's use the whole reciprocal thing to get cotangent. Okay, so if I take the reciprocal of 0, what's the reciprocal of 0? What's 1 over 0? Undefined. So each point that I have undefined, or 0, is now going to become undefined. So this one is going to become undefined. Sort of. Yes. So now every pi mark is going to be an asymptote. Yes. Okay, now each of the zeros, or sorry, each of the asymptotes, I'm hiding behind the pillow.
Can I see calculator for interview? For you to
Oh, yeah. If she was here. She's not here. Sorry. Okay, so I got each of the 0 mark, or each of the asymptotes, because each of the asymptotes was like 1 over 0. So if I invert that, that's now 0 over 1, right? So each of my asymptotes is now going to become zeros. Okay, if I take the reciprocal of 1, what do I get? 1. If I take the reciprocal of negative 1, what do I get? Negative 1.
opposite direction.
Yep. So now notice that since my asymptotes shifted, the direction changed.
Why did it flip?
They flipped because now the one is on the left hand side. Whenever I did this, in between my asymptote, see over here with my asymptote, going from left to right, I went from -1 to 1, right? So that's increasing. Well, now, whenever I inverted all these, I shifted my asymptotes from here to here, correct? Well, now, going from left to right, I'm going from 1s to -1, so now I'm decreasing. So that's why I'm going down now. Yeah, I'm...
So the points stay there, but you just kind of move it over and then like restart or something.
I'm also, I mean, another way of looking at this is I'm inverting everything, correct? I'm doing the reciprocal of everything. So these points in here, in between 0 and 1, these were all small fractions, correct? If I take the reciprocal of a small fraction, it becomes a huge number. So all these small fractions are now huge numbers, so they're all up here now. These huge numbers that were over here, whenever I take and flip them over, they're now small fractions. Okay, so there's cotangent. All right, cosecant and secant. Now I'm going to play with these a little bit. Cosecant is the reciprocal of which one? Sine or cosine? Sine. So what I'm going to do is real quick, I'm going to graph sine of x in red. And trust me, I have a point to this. I know what I am doing, even though most of the time it doesn't seem like it. Okay, so sine starts, oh, I should put my 1s in. 1, -1. So sine starts here, goes up here, back down. Let me go backwards a little bit. That should be good. Okay. Now, cosecant is the reciprocal of sine. So let me take those values and flip them over. So every place that has a 0 becomes what? Undefined. So every place I have a 0 is now an asymptote. Okay, every place that's a 1 is still a 1, correct? Every place that's a -1 is still a -1. So this point, and this point still exist. Now, if I take numbers that keep getting smaller and closer to 0, what happens whenever I take the reciprocal of those? They become larger, right? And the closer I get to 0, actually the closer those become to infinity. Right? The smaller the fraction, if I take the reciprocal of it, the huger the number. if huger is a number or is a word. So this actually gets, whenever you do the reciprocal of it, it flips it inside out, sort of. So if you could cut it and flip it inside out, it would look like that. So that's what cosecant looks like. So if you ever have problems graphing cosecant, what you can do is you can graph sine and then flip it inside out. So secant works the same way. We can take and we can graph cosine and flip it. Yep. Okay, so cosine starts up here. Oh, I should have labeled that. 1 and -1. Okay, so I can do that. And then again, every place where I have a 0 becomes an asymptote. Every place I have a 1 or a -1 stays the same. And then instead of going down, I go up. Okay, so there's your base functions. So then I have some playing with amplitude, period, and translating, so we can do a few of those, and then that's it. I want to take it so badly. I actually don't want to take it. I want to be a jerk. I want to sit here and go, does this help? Can you see it now?
Oh my God, Mr. Gillette.
What? Point on the origin is 0.
Yeah, that's what
What?
you're saying. This point. Right, yes.
That's 0,
How
0.
can there be 0 on here, sir?
There's not.
Exactly, so how's there 0 on that?
What?
What? Mom is 0, 0. Your face.
So you can screw around, but I can't believe it's on board for you.
I am teaching.
You just
Are we good?
No.
Oh my goodness.
You always want to cut or something. That's swindling. Hustling.
And let me guess, next thing you're gonna add numbers and cut.
Well, of course. I'm going to do that kind of stuff. Oh my god!
Oh no, no.
I'm turning old!